Welcome to the MS SQL Tips webcast, Deploying SQL in the Cloud, 5 Things You Need to Know, sponsored by SIOS Technology. I'm Greg Robidoux, co-founder of MS SQL Tips and today's webcast host. Our presenters today are Dave Birmingham, who is a Microsoft Cloud and Data Center MVP, and Tony Tamarchio, who is the Director of Field Engineering at SIOS Technology. Before we get started, if you have questions, you can submit them at any time during the webcast by entering your questions in the question area in your presentation controls. We'll try to answer as many questions as possible during today's webcast. If you have any technical issues with sound or screen quality, also use the question area to let us know. If you're not already a member of the MS SQL Tips community, we invite you to join. You can go to www.mssqltips.com, sign up for our newsletter, read any of our tips, download white papers, and watch any of our archived webcasts. This webcast will be recorded and archived for future playback, and you'll receive a follow-up email with links after today's event. So at this time, I'm going to turn things over to Dave, and he can get started.
Great, thanks, Greg. So again, today, we'll be talking about moving your SQL Server to the cloud. My name is Dave Birmingham. As Greg mentioned, I'm a Cloud and Data Center MVP. Before that, I was a High Availability MVP. So, as an employee of SIOS Technology for the past 13 years, I've really had an opportunity to focus exclusively on high availability and disaster recovery, and so that's where I spend all my time. And recently, cloud has been exploding, so we're helping customers move to the cloud all the time. So I'm constantly hearing about what's working, what's not working, what are some concerns, and what people are have to think about as they're moving their workloads to the cloud. And of course, Tony Tamarchio is going to talk to you today about SIOS Technology as our sponsor. So here are my 5 tips when I start thinking about this and try to think about the important things that I think any person thinking about moving to the cloud, specifically moving SQL Server to the cloud, these are some of the 5 things you definitely need to consider. So we're going to go through each of these in detail, but just to summarize, we're going to talk about building your team, understanding your cloud service level agreements, understanding licensing in the cloud, SQL Server, Windows, so forth, how the instance size can affect your performance, and then high availability and disaster recovery and choosing the right solution for that. So let's jump right in. First off, let's just do a quick poll just to get a feel for what cloud providers are currently using or considering. So, Greg, if you want to put up the first poll question, we'll just take a second up front here to get a feel for the audience.
All right, the poll is launched, so it just gives everybody a little bit of time to answer, and then we'll reveal the results after we get all the voting done. And I give another 10 seconds there. We'll close this and show the results. All right, I'm going to close that and share the results. So we have 52% says Azure, 24% Amazon, 16% not moving SQL to the cloud, 6% other, and 2% Google.
Okay, great. It's good to see Google on that list for the first time. I think I've seen that. I know they just made some announcements this week that they're kind of all in on Windows instances in the cloud and SQL Server, so really be interested to see how they compete in this landscape. But it's not surprising that more than half listed Azure. That's kind of what we're seeing as well. We're seeing a very big uptake in Azure, and of course Amazon is also a good percentage of the mix there, so that's good to know. Okay, so moving forward, when you're moving to the cloud, it's really you're just using the cloud's infrastructure, servers. So, and you're still going to need the same type of players on your team. The cloud, whether you're moving to Azure or Amazon or whatever, it has a concept of a virtual network. So you're going to need people who understand routing, access control, and networking in general. So you're going to have to still leverage your network admins. Storage admins as well. I think storage is probably the most misunderstood or least well documented option in the cloud. So you're really going to have to take some time to analyze the storage that's available to you, and your storage admins can definitely help you there. The good news is that they're not managing the day-to-day SAN, and you don't have to. They're not. Your storage admin is not going to have the same priorities in the cloud, but they might have on-prem, where you're, a lot of times the SQL DBA will be competing or asking for things that the SAN administrator just can't give them or has different priorities. So in the cloud, you really can get what you want as long as you want to pay for it, and the storage admin can give you whatever you want as long as you have enough dollars to pay for it. Security is probably, the top 3 concerns when moving to the cloud. It's an inhibitor. In some cases, you really are trusting when you're putting your business critical data in the cloud that it's going to be secure. So you're going to want to make sure that you have security experts who understand what security the cloud has in place. Does it meet all of your HIPAA requirements or whatever your industry requires in terms of security? You got to make sure that they've checked all the boxes. In some cases, you might have to pay extra for, having your own private part of the cloud or whatever it might be. So you're going to definitely need to have your security admins in place, looking at all the different aspects from data encryption, at rest, in transit, and so forth. So security is definitely a big concern into the cloud. And of course, your database administrators, we'll talk about SQL Server in the cloud, but if you're just kind of going to run SQL Server on some cloud instances, you still need your database administrators are going to install, configure, manage the whole SQL Server, just like they would on-prem, but now running on cloud instances. That is, unless, of course, you're leveraging platform as a service. So Azure, SQL, or most of the cloud providers will have some sort of, if not Microsoft SQL Server centric, like Azure will have a very Microsoft SQL Server centric offering, whereas in Amazon it might have something built more around MySQL. But that's another option that you could think about, and we'll talk about that a little bit later. If you're using the platform as a service, not quite as important to have DBAs, just different level, because the cloud provider is then actually managing that relational database for you. And of course, your developers, you're going to have your developers going to continue developing, whether it's on-prem, in the cloud, or a platform as a service. You still need those developers to build your solutions. And your help desk, they're going to have to learn a whole new paradigm. They're going to have to understand what customers might run into in the cloud. What are some of the issues that they have to deal with on-prem? From network access to the cloud to just managing or monitoring the cloud health. I know I just been looking at some Office 365 deployments, and they have little apps put on your smartphone, and like these alerts, all the time. If there's an issue they're developing. So it's just some new tools, new technology for your help desk to understand, but you definitely need those players as part of your solution. And all that together, you really comes up with a new job description for all of this. You got a cloud administrator. That cloud administrator really needs to understand each of these roles. They might not be a security expert, but they need to know enough about the cloud to be able to overlook their security admins to make sure that they're doing everything, leveraging everything properly. So it's someone who knows a little bit about networking, about storage, about virtual machines, and SQL Server. So the cloud administrator is a pretty new role, and I think it's a great title for you to have, and there's probably a lot of opportunity out there for your, you have experience and expertise in the cloud. So just, moving to the cloud, one of the first things you need to understand is what the cloud provider is offering in terms of a service level agreement. And if you don't look very hard, you might think that moving to the cloud, you can just sit back and put your feet up and, wow, that's someone else's problem. I don't have to worry about that because, Microsoft's going to make sure my SQL Server stays up and running, right? Well, no, not really. I'll use Azure as an example. If you start looking at the service level agreement, you'll see pretty quickly 99.95%. Well, that sounds reasonable in terms of a level of availability. But you start thinking a little bit deeper, that 99.95% only guarantees what I call dial tone. So the instance is pingable, someone can make a connection to it, and it only is guaranteed if you take some steps, additional steps to qualify for that. So to guarantee the 99.95%, you're going to have to put 2 instances in what Microsoft will call an availability set, and then they guarantee at least one of those instances is available. Okay, so that's great that's maybe your application servers or maybe your web servers where the data is pretty static and you can throw up a bunch of web servers and put them in an availability set and load balance between the servers. That's good. But when you start talking about SQL Server, well, now we're talking about some additional requirements. Putting up 2 SQL servers and load balancing between them isn't any good because each instance is going to have a different set of data. So you have to have some way to ensure that the data is in sync between the servers, some level of availability. So we're going to talk about availability options later in the group. But beyond that, SQL Server is traditionally going to have additional storage attached to it. So in Azure, we're talking about putting maybe some premium disk attached to it, or in Amazon, we're talking about putting some additional EDS block devices attached to it. Well, the storage has an entirely different SLA than the instance. And the SLA, I'm going to use Azure as an example, the SLA for storage to guarantee writes to the storage is only 99.9%. That's significantly different than 99.95%. So now your SLA for SQL Server is no longer 99.95. It's really 99.9. And that guarantees that the storage and the server, if you configured it properly, will be available. But it doesn't really guarantee that SQL Server, the application itself, the SQL Server service is going to be up and running. So you still need to take steps to make sure that the SQL Server is actually running and doing so. So then you start looking at traditional clustering technology. All right, so beyond that, here's a list of some other areas that you also need to consider in availability. I mean, you're in the cloud, if, depending upon where your clients are connecting, internet has got to be up and running. You got to be able to connect that instance. The cloud platform itself, I mean, you're not typically losing the whole cloud platform, but it has happened. Now, the service level agreements usually are you're configuring instances within the same geographic region, but that doesn't guarantee them protect against natural disasters that might affect an entire region. So you'll have to address that for disaster recovery purposes. We talked about the virtual machines and the storage being covered by two different levels of SLAs, but again, the weakest link is going to be your best SLA. Beyond SQL itself, your application servers need to be highly available. So again, putting them in an availability set with load balancer, you're going to have some availability there. And then the infrastructure, if you're building failover clusters, you're going to need Active Directory and DNS. All the basic services need to be running, so you need to make sure that you have multiple domain controllers, and they're highly available as well. So there's lots of pieces in this chain, and again, only as good as your weakest link. So moving on to the next point, SQL Server licensing. Should you bring your own license to the cloud? Should you pay monthly to rent SQL Server? Or if you're going to use the platform as a service, what are your options there for platform as a service? And you have to look at what your break-even point is. And you know, for my investigation, what I've seen is you're going to start spending more on the SQL Server licensing sometime around before the 2-year point. So if you're going to be deploying this instance in the cloud and you anticipate you're going to be in that cloud for more than 2 years, you're probably in the long run going to save money by bringing your own license. So that's something to consider. You know, every instance is different and whatnot, but it's something you should definitely investigate as to what your break-even point is. And you know, you want to just do the capital investment up front and be done with it, or do you want to, you know, have that monthly cost spread over time? And that sometimes comes down to, are you passing that cost on to the customer? So I talk to service providers that are just building a service and they're going to sell it to their customers, and they're just going to pad in that monthly cost of SQL Server into their offering. And so that could make sense that you would rent the licenses in the cloud. Platform as a service, again, you know, Azure, you know, SQL Server Azure, if you can leverage the platform as a service, that could be, you know, a significant cost savings. It's typically cheaper than, you know, renting SQL Server itself. But there are limitations. You know, the SQL Server offering in Azure is not exactly 100%, you know, feature for feature parity there. Typically, if you're building a new application, platform as a service is definitely an option you should look at to see if you can coexist with what they're offering. If you're migrating existing on-prem applications to the cloud, usually it's a lot more complicated to try to conform to the requirements of the platform. And it'll be more costly to do that transformation. So you have to look at the benefits of that as well. I think probably the biggest thing here is, how does SQL Server always on impact licensing? So we're talking about availability. Usually we're talking about provisioning a active passive cluster of some sort, whether it's always on availability groups or a failover cluster. Where on-prem, if you have software assurance, Microsoft only requires that you buy one license for that instance. So the passive node does not need to be licensed. Well, as of the last time I checked, just recently, the cloud providers, if you're spinning up an instance with SQL Server to deploy an availability group, and so you're going to need SQL running on the active node and the passive node, you're going to pay for SQL Server for both of those nodes. There's no way for you to say, oh, well, this node's a passive node of a cluster, so don't charge me for that. So your cost is essentially going to double if you rent in the cloud versus bring your own license, because you can't take advantage of the free passive node in the cloud. And then how does the instance size impact licensing? Of course, SQL Server is based on per core, so you're going to spend money for larger, more money. The larger your instance, the more cores, the more it's going to cost. And as we'll see in a moment here, sometimes you wind up having more cores than you need just to get adequate storage throughput or the amount of memory you need. Because it's not like when you build your own server, you can pick and choose. You can buy some really fast PCIe flash storage and throw it in, a server that only has 4 cores if you're not doing, very intensive processing, but you need really fast access. You don't have that flexibility. So sometimes the instance size, you're going to be buying more cores than you actually need just to get the benefit of faster networking or faster storage. So that's something you definitely need to look at because that's going to impact the cost of your SQL Server licensing. And so that comes down to this, choosing your instance size wisely. Again, you're going to have, there's a lot of different sizes, and they're typically offering more, as time passes. Microsoft's coming out with new versions that are geared for different workloads. Compute intense, memory intense, you have basic, and they'll all have different amounts of CPU, different amounts of memory, storage, and network. And so what you need to consider, though, is that one size doesn't fit all. So you might see something that you want that has enough CPU, but then when you start looking at the storage throughput, you really need the next level up. So it really can impact your decision. But the good news is that if you don't get it right the first time, you can resize it generally pretty easily. If you're moving between instance sizes in the same group, like Microsoft, their premier, I'd say their premier instance size for heavy-duty SQL Server workloads is going to be your GS series. It's going to give you lots of compute, lots of memory. The GS5 is going to support the fastest premium storage available, up to 2,000 megabytes per second. So you can move between different G5, GS series instances pretty easily. But moving between different families, it's a little bit more complicated. It's still doable, but that's the benefit of the cloud. If you purchase an undersized server on-prem, it's pretty hard to pack it back up and ship it back to your hardware provider and ask for a bigger server. You always have more RAM and whatnot, but it's not quite as easy. And then finally, we mentioned before your service level agreement. Generally the cloud provider is not going to give you any sort of SLA for SQL Server, unless maybe the platform as a service will be covered under some sort of SLA. But if you're going to host your own SQL Server instances in the cloud, then you're going to have to manage SQL Server availability on your own. It's typically just like you have on-premise. You have all your classic options like log shipping, database mirroring. Of course, backups and restores, that's in the same realm of availability. If you need to, putting it in the cloud does not negate the need to do backups. But when we start talking about high availability, really the two solutions out there today, that same as on-prem, is going to apply in the cloud, where you can deploy always-on availability groups or a always-on failover cluster instance. So this is just a quick list of the benefits of each of those solutions. The availability groups, which was introduced in SQL Server 2012, Enterprise Edition, does feature a quick failover, and the benefit of the availability group is, SQL Server is actually actively running on each node, so you're not waiting for SQL Server services to start up. So when a database switches over, it usually does it quicker than a failover cluster instance because you don't have to start SQL. It does have the benefit of a readable secondary, so you can use your passive instance to do reporting or to take a backup, and so you're not impacting the production. But at that point, then you do have to pay for that license if you're using it as a readable secondary. It also does some automatic page repair, so as part of that process, it can help you in that aspect. And it comes, with SQL Server Enterprise Edition, doesn't require the addition of any third-party products, which, if we look at the failover cluster instance, the biggest inhibitor of deploying a failover cluster instance is the cloud. In the cloud is the lack of a SAN or some sort of shared storage device, where a typical failover cluster will require a shared storage device where all of your data resides. The cloud, or at least Amazon and Azure and Google, I know as well, does not have a SAN that meets the requirements of a cluster. So the SAN needs to support SCSI 3 reservations, needs to be highly available, highly scalable, and so forth. So the cloud providers have storage that just attaches to each instance. And that works fine for availability groups, but in a failover cluster, without that SAN, you're not going to be able to build a failover cluster instance unless you use some sort of shared third-party storage device like Tony's going to tell you about with the SIOS Datakeeper solution that will keep the data replicated between the instances and present the local storage as a shared storage device for the cluster to use in that failover cluster. And so if you do that, the benefits of the failover cluster instance are that it protects the entire instance. So it protects all the user-defined databases plus the system databases, so your agent jobs, your passwords, your user accounts, any schema changes, all that is automatically protected, replicated without any additional configuration. Once you configure the protection for the instance, every change you make on that instance is automatically protected and fails over. Failover clustering also supports distributed transactions. So if your application requires support for distributed transaction coordinator, failover clustering is the only way to go for a high availability solution. It also works with SQL Server Standard Edition. So SQL Server Standard will support a 2-node failover cluster, so it gives you high availability at a fraction of the cost. The difference between standard and enterprise can be quite substantial, so you're going to have a cost savings there. And then if you still have applications that require SQL Server 2008 R2 or earlier, before availability group was an option, you can build failover clusters. Failover clustering has been around forever. That's the de facto high availability solution, so that still works today in the cloud. And again, like I said earlier, once you set it, configure it, you don't have to really think about it after the words as you add new databases. It's automatically part of the cluster. You don't have to configure any additional availability groups. It just is automatically part of the cluster and is replicated and highly available. So that's my take on 5 things that, if I were just dabbling my feet into the cloud, I wish someone would tell me, things I need to consider. So let's put up the second and last poll question, which is how you're currently protecting SQL Server. Get a feel for the adoption of all the different options we mentioned here.
All right, the poll's launched. We'll just give everybody a chance to vote on this, and then I'll share the results as well. I got a good amount of people voted so far, so let's give another 15 seconds and we'll close this and share the results. All right, let's close that. Share the results. So we have 30% always on availability groups, 30% failover cluster instances, 20% none of the above, 13% database mirroring, and 7% log shipping.
Okay. Yeah, that sounds about right. Database mirroring has been around for quite some time, and I really think of availability groups as kind of the next generation of database mirroring. Microsoft has been saying for the past few releases that database mirroring is deprecated, it's going to be going away. They did, with SQL 2016, introduce basic availability groups, which is kind of almost identical to database mirroring, but it's available in the standard edition. So I think they're kind of gearing up for dropping that database mirroring, because at this point they have viable offering on that can replace database mirroring on the standard edition platform. But that's good to know. So all those solutions will work in the cloud. So you can move your on-prem into the cloud and still leverage what you're used to on-premise. So with that, I'm going to turn it over to Tony Tamarchio, and he's going to talk to you a little bit about, I think, describing the SIOS solution that is one of the solutions that will enable you to build failover cluster instances in the cloud.
Excellent. Thanks, Dave. Lots of great information on things you really need to consider as you move SQL Server into the cloud. And to build on what Dave has covered, I'm going to take this one step further and talk about how SIOS enables the deployment of SQL failover cluster instances in virtual and cloud environments. So as Dave mentioned, you've got a number of different availability options when it comes to SQL Server, HA and DR. Again, that's, as we saw in the poll results, some of you are doing just simple backup and restores. You've got log shipping, database mirroring, availability groups, and really the failover cluster instance option here really provides you with maximum availability, full instance level protection, ease of administration. So you'll definitely want to, if you're not using a failover cluster instance today, definitely want to consider deploying an FCI. So we're going to get into some of the options and how you can make this happen here. Just quickly, a bit of background on SIOS technology. So SIOS technology is formerly known as Steel-Eye Technologies. We've been around since 1999 in the high availability and data replication space, protecting both Windows as well as Linux workloads here. So we've got folks around the globe of all shapes and sizes protecting mission-critical SQL servers as well as other applications as well in physical, virtual, and cloud environments. And as Dave mentioned, most of the activity that we're seeing these days definitely is as people move to the cloud, whether that's primarily Azure or Amazon, but other cloud providers are popping up here as well. The biggest challenge in deploying what you're used to using on-premise, which is a SQL failover cluster instance. The biggest challenge there is, again, the requirement for shared storage. And SIOS has a product called Datakeeper Cluster Edition, which solves exactly that problem. It's a software-based solution. It provides real-time, continuous block-level replication that is cluster integrated and cluster aware. And this lets you deploy what we call a SANless cluster. More technically accurate term would be a shared nothing clustering architecture, because you're dealing with cluster nodes that don't have shared disk. So it makes it an ideal type of solution for deploying a cluster up in the cloud, where you've got different virtual machines up in the cloud provider's infrastructure. Each virtual machine has its own independent storage that can't be used as part of a typical cluster configuration on its own here. So this is certainly an excellent way to protect and make SQL Server highly available in the cloud, but if you have other applications as well, this can be used for other applications. You can go with a single solution to protect all of your mission-critical Windows-based applications. So let's dig into some of the details here. So for those of you who have set up a traditional cluster on-premise in the past, this is what you're used to. You've got a couple of servers, you've got some shared storage, and your SQL database, your application can fail back and forth. But technically, in this type of an architecture, the shared disk is a potential single point of failure, and the whole idea behind a cluster is to eliminate any and all single points of failure. That's why you have redundant servers. You want to have redundant network, redundant paths to your shared storage and things like that. But if the shared disk does go out, that can take out your entire cluster. So that's one issue. If you were even able to achieve shared storage up in the cloud, but in most cases it's just not available to you, or it's just not practical for a number of reasons as far as using that with a cloud deployment here. So what Datakeeper does is it's software that installs on your cluster nodes. It's basically been implemented as a filter driver. It sits right underneath NTFS, and as data is written by SQL Server or any other application, the writes are split. One copy of the data goes to server 1 on the left, the source. A copy of that data gets transmitted over the network, either synchronously or asynchronously, to one or more targets. So here we've got a simple two-node cluster, and depending on whether your cluster nodes are in the same region or data center, whatever the cloud provider uses as far as its terminology goes. If it's in a single site, single data center, you're likely going to go with synchronous replication, so you have maximum data protection. If you're doing the geo cluster, where perhaps you have one instance on the west coast, another instance on the east coast, you're more likely going to go with asynchronous replication in that type of situation. So Datakeeper supports both, and you can select the mode of replication that makes most sense for your business based on your recovery point objectives. If your business can't sustain data loss or not, you have to make that decision, and you can select the appropriate mode of replication based on that. Now, because Datakeeper is cluster integrated and cluster aware, if and when you fail over SQL Server to the other cluster node, it automatically updates the direction of replication. So the server on the right, which used to be the target, now is the source, and vice versa for node 1. When node 1 comes back online, data will automatically be resynchronized back to get that server caught up, and it's a partial resynchronization. So we keep track of the data that's changed while the mirror was interrupted, and we get you back up to speed very quickly. So you're certainly not limited to two nodes, although two-node cluster configurations are definitely the most common. Depending on your business requirements, you can deploy 3 or more node failover clusters. And just keep in mind some things like, as Dave covered with SQL licensing, if you've got SQL Standard Edition that supports a two-node failover cluster. Let me go and back this up here. If you want to have 3 or more nodes in a single failover cluster, then that's one reason you might need to make the jump back up to Enterprise Edition if you're looking for that level of availability. Now you certainly could have some flexibility. Maybe you want the third node in the cluster, maybe you want the third node out of the cluster. So you have lots of different options, and really it all comes down to your recovery time and recovery point objectives here. Now Datakeeper does support multi-target replication. So in this type of a scenario, you can have one server that's, in this case, server 1 will replicate to server 2 and server 3 in parallel. You can even mix and match replication modes. So you might have synchronous replication between node 1 and 2. Perhaps they're in the same region or data center. And then you would have asynchronous replication to node 3, which would be in a different region or data center. So that type of a configuration is really the best of both worlds. It's both HA and it's DR, because now you can fail over both locally, if you have the failure of an instance, or you can fail over remotely if an entire data center or region has an outage here. So lots of different ways to protect your SQL Server and ensure that it's highly available. Now, what if you have an existing cluster on-prem, and perhaps you're not ready to make the jump completely up to cloud, but you want some added protection, and perhaps you don't have a second data center, you don't want to make the investment in a second data center, so that's another great use case where cloud can come into play. So the diagram that we have up here on the screen is what I would call a 2x1 cluster. So this is where you might have a traditional shared disk failover cluster in one of your own data centers, and then you add a third node. Again, this third node could be either part of the cluster or it could be a standalone server, and Datakeeper can replicate the shared disk up to the third system, the standalone disk on the third system. Really, the only requirement here is that the derived letters and sizes match. And of course, with any replication solution here, whether it's Datakeeper that's replicating your disks or whether it's availability groups that's doing database level replication, what's really important to consider and understand is your data's rate of change and how that compares to the bandwidth that you're going to have between your systems here. And as Dave mentioned before, sizing is definitely an important aspect of this whole task here. And based on experiences we've had with customers, definitely different instance sizes depending on your cloud provider, can have different bandwidth to both the storage and the network. So you definitely, take a look and try to understand what your workload requirements are going to be. What does that translate into as far as your disk I/O requirements? More specifically, what we really care about here is disk writes, because when data is written, we want to replicate those changes. Reads don't generate any replication traffic here. So a great way to identify with Datakeeper how much bandwidth you're going to need is simply pull up perfmon. Look at your logical disk write bytes per second counter. Let that run for some representative time period, and that's going to tell you how much bandwidth you're going to need between your systems. Again, whether that's within a region or data center or across regions or in a hybrid config where you've got systems both in your data centers and up in the cloud, whatever the case might be, understanding your rate of change versus bandwidth is going to be critical to making this successful here. So I've got a couple diagrams here that talk about what this looks like in both AWS and Azure, which based on the poll, that's a majority of folks here are using those cloud providers here today. So in AWS, when you deploy a failover cluster, the first thing you want to do is make sure that your cluster nodes reside in different availability zones. And you actually, ideally, you want to pick a region that has 3 availability zones, because with a failover cluster like this, where you don't have shared disk, you're going to be using a file share witness instead of a disk witness. So for maximum availability, you want to make sure that the node 1, node 2, and the file share witness reside in different availability zones so that an outage of an AZ doesn't take out multiple components of your cluster, and that can have impact on your cluster quorum and all that fun stuff. So here, you've got a 3 availability zone configuration. Now, one other thing that is AWS unique here is when you deploy, or AWS specific, is when you deploy a multi-availability zone cluster, you're going to end up with cluster nodes on different subnets. So you have a multi-AZ, multi-subnet configuration here. So you're actually going to have a cluster role, as we'll see in the demo later. I'll show you talk about virtual IPs, but you're actually going to have 2 virtual IPs, one in each availability zone. And a key to making the connections into your cluster successful, and something that a lot of people often overlook, is you have to go into the EC2 web interface and you have to define those cluster virtual IPs as private secondary addresses. If you don't define it in the EC2 interface, even if the cluster brings the virtual IP online, you're not going to be able to connect into it. So that's something people often overlook. So I bring that up here as part of the setup. Okay, now if we move over and take a look at Azure. So again, the diagram looks almost identical. You've got a 2-node configuration or 2-node cluster with a file share witness. And here, some of the terminology is different. So instead of availability zones, you end up, as Dave mentioned, you put your cluster nodes and ideally your witness into an availability set, which makes sure that your cluster nodes reside in different fault domains and different update domains. That protects you against both planned and unplanned outages that might take place in Azure. Okay, and one other thing that's Azure specific here is connecting into virtual IPs like you're used to historically on-prem with failover clusters. It just doesn't work out of the box in Azure. It doesn't support gratuitous ARPs. You can't connect into the virtual IPs. So because of that, Azure provides a feature, they call it an Azure load balancer. And you create an internal load balancer, and you put that basically in front of the cluster that probes the cluster nodes, and it figures out which one is active, and it routes traffic to the currently active cluster nodes. So that's one slight difference or gotcha in deploying a failover cluster up in Azure. Might be different than what you're used to doing, certainly different than what you're used to doing on-prem. So, Dave covered a lot of the kind of differences between a failover cluster and, using availability groups. Definitely, it comes down to cost, when you're dealing with standard versus enterprise. Can deal with ease of use and administration, because with a failover cluster, you've got a single SQL instance that's highly available, and whatever you change in one place is automatically failed over and replicated. So a lot less administrative overhead here. Also, you do get full instance level protection with a failover cluster instance, as opposed to availability groups that's only going to protect your user databases, and requires more work to reconfigure things as you add or remove databases here. So, this slide here talks about what things were like prior to SQL 2016, and as Dave mentioned before, there were some enhancements to availability groups in SQL 2016, where there is now a basic availability group in Standard Edition. There is some better compatibility with distributed transactions, but there's still limitations in that area. And then availability groups has added and enhanced the number of nodes that you can have in an HA configuration. So with that, I'm going to switch gears, and I'm going to bring up a live demo, show you what Datakeeper looks like and how you can configure it with a simple three-step wizard, and then we'll go ahead and open things up for Q&A. So here I have a typical Windows Server failover cluster. So if you didn't know any better, if you didn't dig any deeper, you might just think this is a couple of servers and I've got some type of shared storage. In reality, I have two instances here. They each have their own independent disk, and I've just made sure that the drive letters and sizes match. So my cluster nodes are called SIOS 1 and SIOS 2. And if I go up and look at the cluster itself, you're going to notice two differences from what you're used to in a traditional shared disk cluster. The first is, here I've configured a file share witness instead of a disk witness, also known as a quorum disk. So I don't have shared storage, so I can't use a disk witness here. So I've got a file share witness. You can put that really on any Windows server you've got. If you don't have a dedicated system for that, what I will typically do is just put it on an existing server, throw it on my domain controller or some other server that's going to be online here. So that's one difference. The second difference is with the cluster storage. So with the cluster storage here, instead of a shared disk resource, so what Microsoft called a physical disk resource, what Datakeeper provides is a third-party storage class resource called a Datakeeper volume resource. It's a replicated disk that looks and feels and acts like shared storage to the failover cluster. And if we take a look at my cluster roles, here I have a highly available failover cluster instance of SQL Server. This looks familiar. Got my network name, got my virtual IP. Again, in Amazon, you would actually have two IPs, one for each subnet in each availability zone. And then here we've got the Datakeeper resource. This is my Datakeeper Volume S. So this replicated disk resource looks and feels and acts like shared storage. The way that you get this into the cluster, let me go back to disks here, is you pull up the Datakeeper interface, and you go ahead and you can create a job. So I go in here and I can say create a job and go through a simple three-step wizard. I've got an R drive here that isn't mirrored just yet, and I'm going to replicate that and go through a simple wizard where I'm going to pick my source, my target, and my mirror options. So my source will be node 1, SIOS 1. I'm going to select the R drive to replicate that. Step 2, I'm going to select my target. Really nothing to change here. Everything's been pre-filled out, pre-selected for me. And then finally, on the last step, I'm going to select my mirroring options. Here, because these two nodes are in the same data center, I'm going to go ahead and leverage synchronous replication for maximum data protection. We do also have compression and throttling features built right in. And go ahead and click Done. So that's it, simple three-step wizard. It's going to create this new mirror, and in just a moment, it's going to ask me if I want to register this with the failover cluster. And I'm going to go ahead and certainly say yes here. And if I go back into Failover Cluster Manager, now at this point I have this brand new Datakeeper Volume R sitting right there in the cluster's available storage pool. And at this point, this is just back to clustering 101. This disk resource acts and looks and feels like a shared disk. And at this point, this is where you would install your failover cluster instance of SQL Server into the cluster and go halfway through the wizard, and it'll ask you which cluster disk you want to use, and you would just check the box next to Datakeeper Volume R. So very, very simple. Again, if you've ever set up a failover cluster instance in the past, you're familiar with 99% of how this all works here. So I'm going to bring back with that. We're going to open it up for Q&A. So Greg, if you could help us out with some of the poll questions, we'll go ahead and...
Okay. All right, let's see. We've got a bunch of questions here. If anybody else has questions that they want answered, just type them in the question area and we'll get to each of the questions one at a time. So the first question here is related to SANless clusters and any impact on application performance. Just wondering, does it doing something SANless cause a performance hit?
Sure, good question. So Datakeeper supports both synchronous and asynchronous replication. So with any replication solution here, this is that classic trade-off of performance versus potential data loss. Now that said, here at SIOS we've done a lot of work and put in a lot of effort to really optimize and make the Datakeeper product as efficient as possible when it comes to replication. So if you go with synchronous replication, when writes come down, it's a double commit. So the round-trip latency between your source and targets will have some impact on your write performance. Now reads, with either mode, reads are not impacted at all. Now on the flip side, if you go with asynchronous, there won't be any noticeable performance impact to your writes, but in the event of a hard failure, there could be some in-flight data that had been written to the source or the primary node but hadn't quite yet made it over to the standby system. You're generally talking, handfuls of blocks, not like hours or days worth of data. It's generally, like a handful of blocks hadn't made it over. But you still do have write order consistency. So you still have crash consistent data with either replication mode here. So again, just to reiterate, it really comes down to performance versus potential data loss, and typically that's a business decision that needs to be made. But we support both modes.
All right, great. This next question is related to the availability groups for SQL Server 2016 for the standard edition. And so I'm just wondering, does this only support just one database in the availability group?
Yeah, I'll take this one, Tony. So, yeah, basic availability groups in 2016 support a single database in a single availability group. And so that's fine if you have just one database that you want to protect, but that's pretty much what you had with database mirroring, which was not adequate, which is why always-on availability groups, with groups being the operative word here, was created in the first place. People found that without being able to group databases together to ensure that they move as a group, that they were having issues where a database that might have a dependency on another database might fail over, and so you'd have one database running on one server and another database running on another server, breaking that relationship. And so it really wasn't, a great solution in many circumstances. But that's pretty much what they wanted to do because, like I said, database mirroring is deprecated, and they couldn't just do away with it without giving the customers some sort of replacement option in that standard edition. So that's what the basic availability group is pretty much is going to be the replacement for database mirroring, and pretty much has the same functionality as database mirroring has had for years.
All right, great. And actually, I'm going to just pop up another poll here, just related to if somebody wants to learn more about SANless clusters, and we can just leave this up while we go through some more questions. All right, let's see. Another question here just related to the different cloud providers that Dave had mentioned, and someone just wondering, is it any easier to one provider versus another, or do you have any recommendations going one path versus another?
Yeah, I mean, the two big ones we're seeing most of, Azure, Amazon, like I said, and they each have their own wrinkles, So you really have to look at what your requirements are, pricing, and so forth. I can't say I really have a favorite. I know, I'll give you an example. In I think Tony mentioned this, in Azure, the networking is a little funky in that you have to leverage a internal load balancer for client redirection. But once you learn that technology, it's fine. But that does bring me to another point. In Azure, you are limited into a single client listener per cluster. So you can't have a cluster. Let's say in a failover cluster instance, you can't have a cluster that has multiple instances of SQL Server installed. You can only have a single instance per cluster because you can only have one internal load balancer today. Now I know it's a big request for them to be able to support more, and like the cloud is constantly evolving. The beauty of cloud is new features come out. It seems like every week, so keep your eyes on that. Whereas in Amazon, the availability zones are in different subnets, so now you have the added complexity of a multi-site cluster because each node is in a different subnet, so you're going to have two different IP addresses. So you have to understand multi-site clusters and configure your application so that it fails over quickly. So there's benefits to each solution, and each solution can have some issues you need to overcome.
All right, let's see. The next question here is just related to the replication and setting up Datakeeper. They're just wondering, do you have to use drive letters, or can they use mount points, or is there any requirements to do one versus the other?
A good question. So drive letters are required. So basically the requirements for Datakeeper here currently are that it does need to have a drive letter assigned, it needs to be formatted with NTFS, and then to be eligible to replicate it, basically the volume letter can't be marked as system, boot, or contain a page file. Also, you want to make sure that the drive letter sizes match between your source and targets. Technically, the target needs to be the same size or greater. It can't be smaller because there wouldn't be enough blocks to replicate the entire volume over.
All right, let's see. Another question here is about deployment, and just wondering if there's any way to automate the deployment of a cluster in the cloud.
Yeah, great question. So yes, you can automate that. I mean, with failover clustering, for just it's got PowerShell commandlets to automate all of that. Datakeeper also has a command line interface and PowerShell commandlets as well. And for Azure, we've actually created a template on GitHub which allows you to deploy a two-node failover cluster with file share witness with basically a click of a button. So yeah, it all can be scripted and automated, and depending on your cloud provider, there's different ways to achieve that.
All right, let's see. Here's another question that came in, not necessarily related to the cloud, but just wondering, in a VM environment, they're just wondering, can they use the Datakeeper solution to set up a cluster in a VM environment?
Oh, most definitely. So one of the great things about Datakeeper is that it's server and storage agnostic. So this works in physical, virtual, and cloud environments, or you can even mix and match. So you most definitely could deploy a cluster using Datakeeper, in your own virtual environment as well.
All right, let's see. Another question here is for Dave, just related to doing backups on Azure. Somebody just said it looks like you can only have 15 days of backups for Azure. So I wasn't sure, number one, if that's correct or not. And then secondly, if it is there any recommendation to keep older backups, and how do people normally do that?
Yeah, I don't know. I don't know the exact, with the 15 days, so I can't comment on that. But Azure Backup is just one of the backup solutions, right? You can leverage your traditional, backup solution that you're using on-prem and backup within the virtual machine. And so there's some benefits to that as well. With truncating the log files and so forth. So if 15 days obviously is not going to be sufficient, and most cases you're going to look to do a backup every day minimally, if not every hour, then every week and every month, and you're going to want to keep archives of that. So you should definitely look into leveraging other traditional backup solutions to help make sure that you have the archive history that you want to have for your backups. The high availability, and I always point this out that just because if you implement something like Datakeeper or Failover Cluster, having the real-time replication does not preclude the requirement to do backups. Because real-time replication, if you drop a database on a source, it's going to be dropped on a target instantly. And so you need to be able to recover that database, or some logical data corruption happens. You need to be able to go back in time. So you're going to want to leverage your traditional backup solutions to ensure you can do that.
Okay, we're going to take one more question and we're going to wrap things up. So the last question that came is just related to, are there any maximum latencies for asynchronous replication with Datakeeper? So are there any hard limits to, the latency takes 5 seconds or 10 seconds, or can you still?
No, there's no hard limit on any of that. The latency is really just going to affect, well, depending on your mirroring mode. If you do go with synchronous and you have a lot of latency, that's just going to slow down your writes, even more, because think about the round trip latency between source and target. The write isn't considered completed until it's made it to both source and target and the acknowledgement comes back. So, if you have 80 milliseconds of latency, sure, you could do synchronous if that's your number one priority is zero data loss, but then you have to be okay that each write is going to take 80 milliseconds type deal. So, that's one. With asynchronous, no, there's no limitation there either. We do track. We have what we call a bitmap file that it tracks the metadata about which blocks have made it over, which blocks haven't, and the latency would just have an impact as to how quickly the data gets over there and the acknowledgement comes back that it's been transmitted. But there's no maximum. Obviously, you want to reduce latencies. You want to have as low latency as possible. But if you're dealing with latency, you're likely going to go with asynchronous and just hope that your bandwidth, your rate of change fits within your bandwidth, so that your mirror's not too far behind.
All right, great. All right, I want to thank Dave and Tony for sharing that information today, and I also want to thank SIOS Technology for sponsoring today's event. The webcast was recorded, and you'll receive a follow-up email with links to view the archive and also to download the slides. Also, please visit mssqltips.com to access all of our free SQL Server resources. Once again, I'm Greg Robidoux from MS SQL Tips. Thank you for attending, and have a great day.